Hello, welcome to our online mathematics lessons. Today we are going to look at a very important topic in mathematics, that is mensuration, under which we are going to take a close look at the length of an arc of a circle. But before we look at that, let's look at very few things under mensuration before. So we are going to look at these areas. Introduction, that's the general introduction to mensuration. Then we look at two-dimensional and three-dimensional shapes. Then when we are done with that, we will take a closer look at length of an arc. Now let's start. Mensuration is a branch of mathematics that talks about the length, volume, or area of different geometric shapes. Mensuration is a branch of mathematics that talks about the length, volume, or area of different geometric shapes. Geometric shapes exist in two main forms, and these are two-dimensional or plane shapes, which are also shortened as 2D shapes. Then we also have three-dimensional shapes. They are also called solid shapes. Then in short, we also refer to them as 3D shapes. Now let's look at what 2D or two-dimensional shapes are. Two-dimensional shapes are usually plane or flat shapes which can only be measured in two dimensions, that is length and width. Two-dimensional shapes are measured in only two dimensions, and that is what? The length and the width. An example is a rectangle. Rectangle has length, and also has width, W. So these are the dimensions of a rectangle. So let's look at some examples of two-dimensional shapes. As we have mentioned earlier, we have a rectangle. A square is also a two-dimensional shape. A triangle is an example. We have hexagon, kite, trapezium, parallelogram. Then we also have a circle. These are few examples of two-dimensional shapes. We also have different ones, but we cannot list all of them here. So these are just few that we have for you. Now let's go to three-dimensional shapes. Three-dimensional shapes are solid shapes that can be measured in three dimensions, and that is the length, the width, and height. They can be measured in length, they have width, and they also have height. Look at the example here. We have a rectangular prism, which is generally called cuboid. This cuboid has length, it also has width, and it has height. So we have 3 dimensions. Now let's go further. We have examples of 3-dimensional shapes. We have rectangular prism. We have a sphere. A football is a sphere. We have cone. We have cube. We have pyramid. Then we have cylinder. These are all examples of 3-dimensional shapes. Now let's go to our main topic, the area we are going to look at today under mensuration, and that is length of an arc. Now let's look at the circle here. We have a circle here. This circle has a center O, and it has radius. Now this whole line that forms the entire circle is called circumference. Now we have a portion of the circumference which is called the arc. So here we have a point P and then another point Q on the circle. Now the portion of the circumference between P and Q is an arc. So we have the arc here, which we are calling arc L. Now if you look at the other side, we have another arc. So we have 2 arcs here. So arc PQ, and we have another arc PQ. Arc PQ, we have the one which is longer, and then we have which is shorter. The longer one is called major arc, and then the shorter one is also the minor arc. So let's consider the minor arc here, minor arc PQ, which we are calling arc L. Arc L subtends angle theta degrees at the center of the circle. So the circle is having radius r, and then its center we have an angle theta here, which the angle arc L subtends at the center. Now let's indicate them here. We have the length PQ. We are calling it L. Now we also mentioned that the whole circumference, that's the line forming the circle. From our previous lessons, we got to know that the length here, that the circumference, is calculated using the formula 2 pi r, where 2 and pi are constant, then the radius, which is r. Then we also have the angle that the arc subtends at the center of the circle, which is theta. Then apart from this angle, we also have the angle, the total angle formed at the center of the circle. That is 360 degrees. The total angle formed at the center of the circle is 360 degrees. So what we are going to do now is to generate a ratio between L and then the circumference. You know that L is just a fraction of the circumference, so it's just a portion of it. So you can generate ratio, and then the angle theta is also a portion of the entire angle formed at the center of the circle, which is 360 degrees. So if you look at this, we have L is to circumference, which is 2 pi r, should be equal to the angle subtended by the arc, which is theta, is to 360 degrees. So if you express them as fractions, we have L divided by 2 pi r is equal to theta divided by 360 degrees. Now we are looking for the length of the arc. So what we do is we will make sure L here stands alone. So in other words, we are making L the subject of this whole relation. So what we do, we multiply through by 2 pi r. So if you multiply through by 2 pi r, then we have theta divided by 360 degrees times 2 pi r. So we have this relation, but we can simplify it further. 2 here can go into 360 degrees, so it goes there 180 degrees. So you do your simplification. We have L is equal to theta divided by 180 degrees times pi r. So we have the length of an arc of a circle with radius r, which subtends an angle of theta at the center is given by L equals theta divided by 180 degrees times pi r. So this is what we have. Now let's look at how to apply this relation to solve some problems. The first problem, find the length of an arc that subtends an angle of 60 degrees at the center of a circle of radius 14 centimeters. Find the length of an arc that subtends an angle of 60 degrees at the center of a circle of radius 14 centimeters. Now, since we have the relation, we don't need to draw this, and give given additional information that we should take pi. If you take pi to be 22 divided by 7, we don't need to draw it since we already have the information, we have the equation connecting those measurements. So we just quote the information given. We have the radius 14 centimeters, angle subtended at the center 60 degrees. Then we have the relation L equals theta divided by 180 times pi r. We substitute the values into this relation and we simplify. We get the final answer to be 14.666 becquerel. You can approximate it to be 14.7 centimeters. 14.7 centimeters. The second example. Let's look at the second example. The length of an arc of a circle is 22 centimeters. If the arc subtends an angle of 42 degrees at the center, what is the diameter of the circle? Pi is given to be 22 divided by 7. Now let's look at how to solve this one too. Here the angle subtended at the center is given to be 42 degrees, and the length of the arc is 22 centimeters. We are now asked to find the diameter of the circle. The diameter of the circle. But you realize that we have not looked at any relation between the diameter and the length. What we know is the relation between the length and the radius. But don't forget that there's a direct relation between the diameter and the radius. So we just substitute the values given into this relation. We have this. Now I'll isolate R. So we do the usual algebra. You come to this, that R is equal to 22 times 180 times 7, all divided by 22 times 42. Then if you simplify, you get the radius to be 30 centimeters. We know that the diameter is 2 multiplied by the radius. So if you have the radius to be 30 centimeters, then you multiply that by 2, you have 60 centimeters, and that is the length of the diameter. Now that we have tried these two, I want to give you few examples to try on your own. Just 2 examples here. So try question 1. Find the angle which an arc of length 31.4 centimeters subtends at the center of a circle with diameter 60 centimeters. Question number 2. The angle of sector of a circle is 150 degrees. If the diameter of the circle is 14 centimeters, calculate the length of the arc of the sector. The length of the arc of the sector. So, in both circumstances, we have to take pi to be 3.14. So, work around. These are the solutions. You can cross-check to find out whether you are doing the right thing. Cross-check to find out whether you are doing the right thing. Now, we are going to end our lesson here. But let's look at what we have done today. We have seen a general introduction to mensuration. General introduction to mensuration. Then we looked at two-dimensional and three-dimensional figures or shapes. Then we also looked at the length of an arc, and we came to a conclusion that the length of an arc, L, is giving us the angle subtended by the arc divided by 180 degrees, or multiplied by pi r, where r is the radius of the circle. Then we also applied this relation to solve some examples. We applied it to solve some examples. Now, the next time we meet, we are going to look at this topic, perimeter of plane figures. Perimeter of plane figures. So until then, see you.